So hopefully we can get through this quickly. There's only 3 objectives. Some of this stuff is, I don't know. I'm not going to say it's hard or not hard. I'll let you decide. I've been doing it too long. So we got 3 objectives. Right triangles, bearings. Those 2 should be fairly simple. Might be a little tougher on the harmonic motion. Let's see if I got my notes here. Okay, so you guys ready?
Yep.
Good. Solving a right triangle. The nice thing about right triangles, we can use our right triangle trig. So we can see sine, cosine, tangent, secant, cosecant, cotangent in order to do some of these things. And all we're really doing is they'll give us a couple pieces of the puzzle, and then you have to find everything else. Okay? And how you find that is really totally up to you. I'll show you what probably makes most sense to me, but that's okay. Now, just some notation rules. Usually when we have a right triangle, the hypotenuse is always the hypotenuse, right?
Yeah.
That will always be C. And then you'll have big A, big B. So we have A, B, C. Hypotenuse will always be C. Angle C should always be your 90-degree angle. Opposite to A should be little a. Opposite to big B should be little b. So in general, this is how we describe a right triangle. Angle ABC, side little a, little b, little c. Nothing new, right?
No.
All right, cool. Let's move on. So here we go. Let's do it. So here's what we know. We have a right triangle. We know that big A. So I'm going to just sketch this bad boy. So A, and yeah, it doesn't have to be perfect. The image is for you, right?
Yeah.
So I know that this A is 62.7 degrees, correct? And that little a is 8.4. We have to find all the other parts, which means we need the measurement of angle B. We need to figure out little b and little c. Right? Is that the only things we don't know?
Correct.
1, 2, 3, yeah. Because we know that angle C is obviously 90. Now, how can I find angle B?
You do 180 minus 90 minus 60.
Oh, that's a lot of work. But yes, that would work. I do know that this is 90, so these two should also make 90, correct? So I could just do Sunny 90 minus 62.7?
Yeah.
But you're correct. That will get you there as well. Okay? So what is 90 minus 62.7?
27.3.
27.3?
Yeah.
All right, cool. Now, what do you guys want to go after? Little b or little c? Little b?
Yeah.
Little b is right now. So here's what I need to do. Do you guys want to use angle A or angle B?
I don't know. The big one.
It doesn't matter. That's what I'm saying. It's totally up to you how you approach this problem.
Which one's easier?
They're both just as hard.
C.
No, we're not going to use I said angle A or angle B. All right, cool. Since it's already written there, right? So, okay, so if I'm looking at it from the point of view of A, I have the opposite. I want the adjacent, correct? Which trig function does opposite adjacent? We're just going to throw out random words? Flubber. Tan does, right? So we're going to ask for the tan of 62.7 degrees. Now I know this is just some number. Okay, tan 62.7 is just some number. And it should equal its ratio, which happens to be 8.4 over b. And then we're just going to algebra this for now.
Multiply by b.
I'm going to multiply both sides by b. And then I can, I'll just write it again. So I'll get b times this number called tan 62.7. That's going to equal 8.4. And what should I do at this point?
Divide by 10.
Divide by this number called tan 62.7 to both sides. So b should be whatever this quotient is. And according to my handy-dandy calculator, it works better when it's on. 8.4 divided by the tan of 62.7. I got a 4.33. Anybody want to
Correct.
second that?
I got it. Second.
Cool. So I've got 4.33. Let's go 4.34.
Yeah, because there's a
Just for
5.
rounding's sake. So this should become approximately. Because I did round it, it should become approximately. Okay. And then to get C, now we have more options, don't we?
Correct.
Okay. You could do the Pythagorean theorem. Sorry. Yeah, I always say that. With Pythagoras' theorem. The only flaw with doing Pythagorean theorem, Pythagoras theorem, is that we have rounded little b now, haven't we?
Yeah.
We've rounded little b, therefore using Pythag probably won't be as accurate, right? Because we've rounded it already.
Yeah.
And you really want to get used to using the trig for it, okay? So all I really have to do for this one, I have the opposite. I want little c. What uses opposite over hypotenuse? Sine. So I'll do sine 62.7 is equal to 8.4 over little c. And of course, from this math, you can already see that this is just going to end up being 8.4 over the sine of 62.7, correct? So 8.4 divided by sine 62.7. Someone want to volunteer?
What was it? I got 9.45. What'd you get?
You first.
9 point, I got 9.45.
I got 9.45 too. Cool.
What did you get for B? For little B?
Little c, you mean?
No, for little B.
Little b is 4.3455. Actually, it was 4.3355.
No, we ran it to 6.34.
Yes, and we said that, except we rounded little b. So when we throw that into Pythagoras theorem, it'll be a little bit smaller than, because we've rounded it already. But there's nothing wrong with it. Personally, I wouldn't want to be squaring 4.34, but that's just me. And if you want to do that, more power to you. Okay? So, yeah, we're done. We've solved the whole thing. We know all three angles, and we know all three sides now. Yeah, if you didn't, and if you didn't even want to use 62.7, you could have gone with 27.3, done cosine, done tangent, cosecant. It really just depends on how you want to do it. Okay. Now, if you get good enough, you can see. You guys remember how I had this on the denominator?
Yeah.
I could have worked with this easier if I would have done cotangent. That would have
yeah.
put b on top,
then
and all I had to do was multiply both sides.
By 8.4.
You see that?
Yeah.
So if once you get really good at it, you'll see which trig function you're going to want, so that you don't have to do the extra math. I like to depend on my calculator too. Is that good, or is that a question, or we're good? Okay. Moving on.
It's good.
He's good. Oh. Oh, sorry. I moved on without asking anybody. Everyone okay? Yep. Mr. Computer Man. What going on? I was looking for something too.
I'm dragging him down.
Okay. All right. Thank you.
I want to try. Can I try this?
You want to try it first? Is that what you said? All right. I'll give you guys 3 minutes. 2 minutes. 2 minutes. That's giving you 2 minutes to start up this this dojo. point on the level ground of the Eiffel Tower.
Really?
Looks good enough?
Yeah, and then you have the angle going like down from the bit from the
so-
start of the base.
So 80 feet away.
Oh, that's what it means?
Yeah, and then the angle going up.
Angle of elevation.
And then, which is 85.4.
Okay,
I already figured out what big angle B would be.
What's the height of the Eiffel Tower?
That's not.
So they're saying some guy was like 80 feet away, and when he looked up, he had. I'm impressed by how precise he knows how much he had to incline his neck. It's only 85.4, darling. We actually have some of those things that like you can look through it, and it'll tell you how many degrees. Yeah, we have some. You guys want to do that? Go find like the height of the flagpole and stuff. No. I don't want to get cold.
That's amazing.
It's not cold. She's so petite, yeah.
We don't know what A is. But if we did, one of those. Opposite of reducing, right?
I got this.
I'm looking at my notes, and they have a picture. It looks nothing like the Eiffel Tower. It looks like a cell tower. I'm like, that is not the Eiffel Tower. Because doesn't Eiffel have like arches, right?
Yeah, and then you would get, so you would get
It looks more like what I drew than anything.
A over 80, right?
Because I think Eiffel looks like, doesn't it look something like this?
Well, technically you could find a cotangent of that.
I don't know what's on top, but
No, yeah, that would
I don't know. I don't know what the crown looks like. Is it diamond-like or something?
It kind of like curves in.
Yeah. Huh?
It curves in and then it's like everything pretends it's like. Oh my god, Lyra.
Yeah, technically we don't have the words.
Okay, so yeah, Grace.
Something like that.
Yeah.
Really? We're gonna go like into detail with this?
Whatever.
And see that. Hey,
Ugh, that's horrible.
So you got the tan, so you did 80 times the tan of 85.4.
Alright, what'd you get? How tall is the tower? Not the one on your keychain, dear.
I got 64.3.
I
got 2.
Are you guys all in degrees?
Yeah, are you guys in degrees?
Oh,
Wait, what should it be?
Yeah, what
Degrees.
Don't say it, don't say
Okay.
it.
Yeah,
994.3.
Yeah, that's what I got.
994.3.
Well, then it wants it to the nearest split, so it'd be 994.
No, yeah, 994. Alright, cool.
I got 60.
Yeah, they call you a radius.
You guys good or do another one?
Can we do another one? I kind of want to do another one.
I think it's good. We'll come back later on.
I like these.
Let's get to
One time we actually like to do one.
bearings. Trig and bearings.
What are bearings?
Bearings. If you guys go to military, Navy especially. Okay. There's like 4 slides, which I don't think is really necessary, but so I'm gonna go through them. Whenever you start when you talk about bearings, you're either going to go northbound or you're going to go southbound. Okay? So you will go north, north, or you start off by saying south. Okay? So let's first talk about north. The north. Yeah, if you're out in the sea. Actually, I don't think it worked anywhere. It's just kind of where you're headed. Okay? So to talk about bearings, you're always going to start it with north or south. Okay? So, for example, if I was going to go in this direction, okay, I would be going north, and then I would say how many degrees away from north I'm going. So let's say this was 30 degrees. I would do north, 30 degrees, which way? East or west? There's the bearings for that.
Oh, okay.
Make sense? So if I'm going this direction, I'm headed north, 30 degrees east.
You're going northeast.
I'm going north, 30 degrees east. But it is northeast. Yeah, that's pretty much it. That's bearings right there.
Oh, okay. That's pretty cool.
What if I'm doing this,
North,
and I'm doing, let's go 45, sure.
45.
How would I write that?
North 45 degrees west.
North, 45 degrees west. And what if I'm going here?
South 80 degrees west.
How would I do the blue one?
South 80 degrees west.
South, 80 degrees west. And obviously, process of elimination. And the angles are going to be the acute ones, moving away from the north line, always away from the north line or the south line. Okay? So it's not like trig where we always go back up. Okay? Bearings are going to be a little different. So my other option would be I can go in this direction, where this is like 5 degrees. I would be doing south, 5 degrees east. Okay? And that's what all of these slides were for.
Wait, seriously?
Yeah.
They had 5 slides for that?
Yeah.
That wasn't necessary.
I copied them and I'm like, I'm not going to do all those slides. This is ridiculous.
Well, what else do we have left?
Harmonic motion.
They did football?
Just like anything, you just need formulas and what they mean, right? It's raining?
Oh no!
No, it's right. Sorry.
That was so wow.
I need sun. I need sun. I'm a sun rat. But I'm in the shade.
I love the sun.
Sometimes I like the warmth.
Yeah.
Not directly though.
I love it.
Like I don't want to be out there sunbathing. Like, no.
I'm actually funny. Like, I don't I tend a little bit, but I'm still not the same. But like my face, like my face, I just feel like I'm awkward.
Thank you. Let's get back to here. You guys get done copying. I can hear it from the tone in your voices. Okay. Simple harmonic motion. You need these formulas. That's all it really is. Let me go a little bit better. Okay. When you're writing these down, notice the formulas. They look exactly like what we were doing, sine, cosine, right?
Yeah.
I hate exactly like formulas.
They look exactly like formulas. Yeah.
Oh, are you serious?
Way to answer the question within the question.
Oh yeah.
Yeah, you crazy. If it walks like a duck, then it must be a duck, right? That looks like a formula. That is a formula. I love it. That was good. Simple logic,
Have
right?
you seen the video of like yeah, he's like, you know what? Yeah.
That's
We don't have to do it. We don't have to record it.
period of motion.
An object that moves on a coordinate axis is in simple harmonic motion if its distance from the origin D at time t is given by either d is equal to a cosine omega t. That was omega, guys?
Yeah, omega is the W.
Omega, or if it's a times sine omega t.
I don't know what that is.
That means it's just following a sine or cosine curve. Okay? Yeah, but it's called harmonic motion. What is the amplitude?
A.
Absolute value of A. The maximum displacement is what's going to be called. So the amplitude will give you the maximum displacement. The period of the motion is 2 pi over omega. Write that down. Omega has to be greater than 0. If it is equal to 0, then it's undefined. And you don't definitely want a negative number. So the period there, you have a new formula. Well, not really, right? It was 2 pi over b before. Now it's 2 pi over omega instead of b. So none of the rules have really changed, right? In describing simple harmonic motion, the equation with cosine function is used to if the object is at its greatest distance from the resting point, the origin at t equals c. By contrast, you're going to use sine if a is used if the object is at rest position. That should kind of make sense to you. Let's say I had, I don't know, some object, okay, and if it's resting, like a spring or something, if it's resting, it should be at 0, correct?
Correct.
Which trig function starts at 0? Sine. That's what they're saying. That when it's at rest, you're going to start with the sine function. You'll use sine function. Now, if I do take that spring and I kind of yank it, right? I would be starting away from its origin point. Then I would be using the cosine function.
Oh, okay.
Hold up. Are they in order? Like that was cosine, that was sine?
Yeah.
So wait, so T is that?
Sine should always look like the S, and cosine will look like the weird C.
Oh no, where did it go?
So the letter T, is it just like a variable that doesn't really have a?
It would be like X.
Yeah, like
Yeah.
X when it has no. Okay. Like you're
But in
not
this
trying.
case, T is time.
Yeah. Okay. So it's
In
not
this
like
case,
it's not like a variable that you have to find something for, right?
Well, in this case, it's time. So it's not. This is more specific than our generic sine cosine because it's just any wave that behaves that way. Here, specific to harmonic motion. So we can talk about the displacement. We can talk about how fast it would move, and over how much time.
So T, we kind of okay.
Okay.
Yeah.
All right. Then. Here we go. Oh, I already said that.
Yeah.
Okay, here we go. A ball on a spring is pulled 6 inches below its rest position and then released. The period for the motion is 4 seconds. Write an equation of the ball in simple harmonic motion.
So
You guys, a few minutes, you can talk to your neighbor.
Wait. Are these right?
Sine, cosine?
No, I mean, so it'd be negative 6, right?
It's omega.
And then that'd be in front of, that would be in front, and it'd be a cosine at that point because,
Omega.
it'd be a cosine.
We didn't say what omega motion is?
Because, it's pulled from, it's starting at a non-zero position.
Omega is kind of like, you remember what B was? How fast it's moving?
Is that what omega is?
It's still the same thing. Period, correct.
So then
Well, you need it for period. It's not the period because 2 pi over B is the period. Period would be 2 pi over
cosine
So right now it
Omega.
don't matter because basically if you just have a period there without having an omega there.
for omega.
Because that's what we were able to do before, right? We had like x plus period and then we didn't make the omega, right?
What about the amplitude?
Huh?
Oh no, but it's, okay, so it'd be negative 6.
Give me a moment.
In this case, they're giving us period. They already told us what it was.
Is 4.
But that doesn't make that omega, is what I'm saying.
So if you just leave it there, it doesn't bother.
You want to extract omega from here to put into your equation
4 omega?
for harmonic motion.
Would it be 4 omega since it's 4 seconds?
No, period is 4 seconds. How do you find period?
Oh, so it would be 1/2 time.
2 pi over omega. So what does, in this case, what does 2 pi over omega equal? So solve that equation for omega.
Oh, okay.
Ah!
So then it has to be 1/2 pi, right? Because you get rid of the pi.
Okay, I'm not saying so you're starting at 6.
Below.
Because you would one right flip it.
Yeah, so it's going down.
Yeah. Okay, so then it would be 6 cosine of
That's correct.
1/2
But it said that the period is 4 seconds.
Right.
So I literally
How do you find period? Okay, so that's what the period equals, right? Period equals 2 pi over omega. And they told us that omega was 4. So those two things are. Alright, go back. Hold on, ladies first. Hold on. Oh wait, hey! Hey! You were right. I'm sorry, I apologize.
No, a formula is a formula.
Yeah. Because once you know what the time is, you can figure out where it is.
I felt like we're wrong for some reason. Because you get rid of the pies and then you would flip because you don't want to lose a half down here, so you multiply by 2.
It's good. It's great. Yeah, because you're writing an equation to predict where you are on the
Maybe 1/2 t instead of 4. I want to do it first. Yeah. Can you do this problem already? I want to see if I got it right. I got d equals -6 cosine b 1/2 pi t. That's what I got. Okay. Yeah, I did one. Okay, so yeah, we're right. Because I did the 1/2 pi because you would use 2 pi divided by 6. Yeah, okay.
Be good. So, here's how we want to think about this. My function for this is, what do they call it? D?
D, yeah.
The distance, right, is going to be A
Cosine.
cosine. Why cosine and not sine?
Because it's pulled away from
It's
the
pulled
resting
away.
From the resting point.
Omega t. Now, they told me it was pulled 6 inches below the resting
So
point,
it would be -6, correct?
making that -6
Cosine.
cosine. I need omega to plug in. T is the variable that just kind of stays there.
Yeah.
So if you tell me the time, then I can tell you how far away you are on distance, okay? Now, to get omega,
2 pi.
I know that the period is 2 pi over omega.
In order to
That is the formula.
correct.
I was told that it was 4 seconds for the period. So we're going to solve that bad boy.
So I didn't do it that way.
So that should be what, pi halves?
Yeah.
And there's the formula for that.
Sweet.
What? Cosine normally starts above, doesn't it, at positive? That's why when it's away from there. But because we pulled below, that means it started here, didn't it? So it's a negative cosine. If we would have done sine, that means that that ball would have been in its resting.
It would have started at a 0.
It's resting point. That's 0. Because that's the sign that starts at 0, right? Okay?
This is actually, I thought it was going to be a lot harder than that.
No, it's just formulas. You know the formulas, you plug stuff in. Alright, I'm going to end this, and I do want to show you